Welcome to the Q&A session 16 from the chapter of properties of matter. The topic is the calculation of tension in the string due to the upthrust. And based on this topic, I have one question which is written here on this board. And the question here is a metal cube of side 5 centimeter and density 9 gram per cubic centimeter is suspended by a string so as to completely immerse it in a liquid of density 1.2 gram per cubic centimeter. So the tension in the string is, so here there are four options here in this question and we have to find the correct option, and here the value of the G is to be taken as 10 meter per second square. So here first of all we will calculate the mass of the cube, and the mass of the cube will be equal to the density of the cube multiplied by the volume of it. So the density will be equal to 5 centimeter into 5 centimeter into 5 centimeter. Sorry, this is the volume. This is the volume. 5 centimeter into 5 centimeter into 5 centimeter is the volume, multiplied by the density. So density here is equal to 9 gram per cubic centimeter. So here the mass will be equal to 125 into 9 grams, and this is equal to 1125 grams. So the mass of the cube is equal to 1125 grams. Now the weight of this cube this will be equal to 1125 gram force, and since this metal cube is immersed in a liquid of density 1.2 gram per cubic centimeter, so this metal cube will be experiencing an upthrust in the upward direction. So this weight on the cube will be acting in the downward direction, and the upthrust due to the liquid will be acting in the upward direction, and the upthrust will be equal to the volume of this metal cube, which is equal to 5 into 5 into 5, that is equal to 125 cubic centimeter, multiplied by the density of the liquid, which is equal to 1.2 gram per cubic centimeter, into G. So this is equal to, if I calculate this value, so this will be equal to 125 into 1.2. This is equal to 150 gram force. And so the tension in the string will be equal to the weight of the cube minus the upthrust, which is acting vertically upward, which is that is upthrust, so this is equal to 1125 gram force minus 150 gram force. So the tension in the string will be equal to 975 gram force. Now if the value of G is equal to 10 meter per second square, then 1000 gram force is equal to 10 newtons. So 975 gram force. So it implies that 975 gram force will be equal to 9.75 newtons. So the correct option here is C, that is 9.75 newton. So the tension in the string will be equal to 9.75 newton. And in the next session now, that is in the session number 16, I will be coming up with a different type of a question. And the question which I will be taking in the session number 17 will be based on either the Archimedes principle, buoyancy, or the laws of rotation. So till then, have a nice day. Bye.